Thank you so much, Stefan, for this terrific introduction. And of course, many thanks to all of you for joining. I'm Ingo, as said, and today's session, without a big surprise, is all about software testing. And this talk comes in two parts. In part one, I want to share, my notion of software testing. I want to let you know what software testing means to me. That will be part one. And in part two, I want to share some characteristics that make software testing excellent from my naive perspective. So that's the simple logic behind this talk. That's the master plan. I hope that works for you. So let's dive right in. The more and more I'm studying the field of software testing, the more I learn that software testing is like a deodorant. And the reason for this is fairly simple, because the people who really need it never use it. And that's exactly the reason why I'm here today, because I want to change that. And to do that, I want to say some words about my person first. In the last 10 years, I've worked as a product manager for several tool vendors in the automation space. In RPA, that means robotic process automation, and in automation for the purpose of software testing. So I lived and breathed automation. Automation was my daily bread. It was at the epicenter of my professional life, so to say. It truly dominated my daily thinking. And all this told me one important fact about software testing. And that is that I should rather see tools as classes. So by designing tools for the purpose of automation in testing, and by observing what software testers actually do, I learned that tools do not test, just as classes do not see. So tools only help us to test, just as classes only help us to see. Or in other words, the classes don't do the seeing, just as the tools don't do the testing. So the bottom line is that testing is something that doesn't happen in our tools. It's something that happens in our heads. It's a thinking activity. And for that simple reason, I do not reduce testing to an act of artifact management, where you use tools to create, to automate, to execute, and to maintain test cases, for example. Testing to me is so much more than that. And therefore, I like to say that testing is no more about tools than astronomy is about telescopes. And if we would reduce the act of testing to an act of test case creation, and especially test case automation, then I think we also would need to accept the fact that when we are testing badly, would just help us to test badly at an accelerated rate, right? So this means that we need to avoid to automate chaos, because if you automate chaos, all you get is faster chaos. And this usually looks like that. So here is a typical software testing timeline. And this software testing timeline is usually composed of 4 phases. Now, in the first phase, I hear people saying testing, never heard of that. There is only automation. We automate everything. Now, it usually takes some time until those people then start falling down what I like to call the Mount Stupid of software testing. And it's a huge mountain, trust me. But when those people then start falling down that Mount Stupid, they immerse into what I like to call the valley of despair. And in that valley of despair, I hear those people saying, okay, there is testing, and testing is probably more than just automation, but we're just not convinced that we really need it. And you know what? The last 2 phases then often look like this. So now let's zoom into those last 2 phases to see what's really going on there. And now I need your imagination. Imagine that all these dots you see now on that slide represent all the test cases you have, for example, in your regression test portfolio. And now imagine that all these test cases pass in the last regression test run before you decide to ship your product into production. And then you might conclude, well, that looks good, right? So let's ship it. Let's ship our software product. And that is what you then most probably will do. But just a second later, you will see something like this. You will see that repetitive test case execution, no matter if it's done by machines or by humans, is by far not enough to avoid scenarios like that. Now, this is usually the point in time where people start realizing that testing shouldn't be confused with test cases. these people start realizing that testing shouldn't be reduced to the act of creating, automating, and executing test cases. Testing is so much more than that. So now let's dive a little bit deeper into the subject of software testing to understand that a little bit better. And to do that, I need your imagination again. So now imagine that this black rectangle shown on the right-hand side now represents your software product. And it represents the entire functional and non-functional spectrum of your software. And it also represents all the environments your software can be situated in. And it also represents all the people that might use your software. So that's all there is. That's all you could possibly know about your software. Try to imagine that. Now then, the green rectangle represents all what you currently know about your software. And this rectangle is much smaller than the previous one because it's simply impossible to always know everything about your software down to the very last detail, right? Then the red rectangle represents everything you repeatedly check in your software. For example, by automated repetitive regression checking. And again, you will never be able to check everything you know at any time because of the time, the resource, and the budget constraints you are confronted with, every single moment in your daily testing business. And so the question here is, well, would it make sense to try to automate, to codify all your knowledge? Well, most people would say, yes, of course, that's the ultimate goal of software testing. But I'm saying no. Because when you would only aim to automate all your knowledge, then the question is, well, how on earth would you then be able to create new knowledge about the software? And you have to create new knowledge about your software because your software constantly grows. And so you constantly need to create new knowledge about your software to reveal all the problems in your software that are far, far outside your checking regime. Now, that is what software testing is all about, at least to me. Testing is all about closing this knowledge gap. It's all about closing the gap between what we know and what we don't know about our software. So the goal of testing is rather, information than automation, I would say. And the reason for this is fairly simple. A test itself is just a question you ask your software. And the purpose of performing the test is to gain information about your software, to reveal those problems you've seen before. So testing is, always has been, and hopefully always will be a search for information. And therefore, I like to see testing as an information service, not as an automation service. So in its shortest possible form, I would say that the purpose of testing is to collect quality-related information about our software to enable other people to make better informed decisions. That's it. So testing at its core is just about three things. It's about information, people, and decisions. So first, we collect quality-related information about our software. And that's information, for example, about the actual or the potential problems in our software. And then we provide this information to other people, people such as developers, people such as product owners, product managers, support engineers, release engineers, to enable these people to make better informed decisions based on the information we provide. And these decisions might be shipping decisions or fixing decisions, for example. So the bottom line is helping other people to make better informed decisions. So that's the key here. And that is how we create value through testing, from my perspective. Now, this then begs the question, well, how do we collect this information in the best possible way? Or in other words, what does it take to do excellent testing? And I want to give you an answer to this question by telling you a short story. And this story is about Alice. Now, Alice not only is a software tester, Alice is an excellent software tester. Now, excellent software testing is really hard to describe because you only find out what excellent testing is when you see it. So here is what I've seen. Here are 18 characteristics of Alice's testing excellence. Now, before I dive into these characteristics, I want you to do one thing. So I want you to just lean back now. to relax, and also feel free to close your eyes for the next 15 minutes or so, because I have to admit that the next slides aren't super exciting. The story is what truly matters now. So I will now turn this presentation into a kind of a play reading, so to say. And I really hope that works out. Now then, let's get started. Number one, Alice knows that testing is a social science. She knows that the quality of software is inherently subjective. So she knows that quality is valued to some people who matter at some time. And she understands that a bug is just something that threatens this value. So she realizes that a bug is simply something that bugs somebody, because she's learned that a bug isn't necessarily in the software, but rather represents a relationship between a person and the software. And therefore she accepts that quality cannot really be measured, but only assessed. So Alice acts like a sociologist who looks for different problems that matter to different people who matter, because she knows that different people will look at one and the same software as having different levels of quality. Alice also understands that our thinking errors can become software errors when we aren't aware of our cognitive biases. And therefore, she looks for the bugs in the mind of people. So she acts like a psychologist, so to say, who delves into the mind of people to analyze their thinking, because she knows that most of people's knowledge, including their opinions, their assumptions, and their expectations about the software, is in their heads. Alice is also aware that automated repetitive checking is important, because she knows that she cannot trust the software, simply because the software continuously changes its mind. The software and the business, as well as the technical domain in which the software is situated, constantly and rapidly evolve. Now, for that reason, she automates checks to make the process of comparing the current state with some past state of the software faster and less error prone. So she has also learned that there is no such thing as free lunch when it comes to automation, because she knows that automation requires maintenance. And therefore, she treats automation like a cake, I would say, because she knows that a small amount of cake, and therefore automation, can taste great, but too much usually makes her sick. So she doesn't just automate checks. She automates checks that matter. She automates checks that repeatedly reveal useful information about the software. So the bottom line here is that Alice acts like a controller who carefully controls the benefit to cost ratio of automated checks to not get drowned in maintenance efforts. In addition to that, Alice clearly understands that software testing is not a mechanically one-dimensional activity, but a multidimensional, creative, and human-centric activity. And therefore, she sees human testers and their skills at the center of testing, not machines. Now, Alice is also a master in programming, I have to say, but she doesn't feel the need to artificially elevate her role by inventing new names for it. She knows that saying tester is enough, because she understands that she is actually being paid to test, not to code. And for that reason, Alice sees tools as something that can accelerate, that can extend and simplify testing. So she doesn't consider tools as something that eliminates the need for human thinking in testing. She knows that it is silly to blame gravity for falling flat on the face, and therefore she doesn't blame tools for the poor tests she performs. She knows that only poor testers blame tools for the poor tests they perform. So Alice acts like a leader who is leading by example, by holding herself responsible for her actions and accountable for the results of her testing actions. Now, the list goes on, ladies and gentlemen. Alice knows that testing is context-driven. She's aware that there aren't any best test practices out there, only good testing practices in context, because she knows that the value of any practice depends on its context. For example, the project, the product, the people, and the environment. She knows that she wouldn't test an autopilot of an airline in the same way as a website. And of course, sometimes instead of finding and learning how to use a chisel, she sometimes turns to the hammer she's already holding. But in hindsight, she becomes aware of that. And therefore, she equips herself with a variety of testing techniques, such as heuristics. And she has these techniques ready in different forms. For example, in the form of checklists, in the form of cheat sheets, in the form of mind maps. Now, she does so to enable herself to design, to perform, to prioritize, and to analyze her tests in different contexts. So in short, Alice knows that testing is not just a talent, but rather a set of skills that can be learned. She also relates testing to other disciplines such as physics, mathematics, history, philosophy, and social science, for example. And she does that to broaden and strengthen her skills in problem solving, her skills in modeling, speaking, and her skills in critically and lateral thinking, for example. So Alice acts like a chameleon, so to say, that has the ability to adapt to new, unknown, or unfamiliar environments fast. Alice knows that the set of models she's using in testing are just a set of ideas about the software. So she's aware that these models aren't the software. These models are abstract representations of the software. And she's using these models to understand certain aspects of complex software in simple terms. She's using these models to form conjectures, to direct her testing, to make decisions, and to communicate her conclusions. Now, she's aware that these models are simplifications of the software, and she understands that simplicity doesn't precede complexity, but follows it. So she reflects on her conjectures, on her decisions and conclusions by considering alternative models, because she knows that these models are probably flawed representations of the software that are based on her flawed mental model of the software. So she acts like her own best critique, so to say, who questions her own models in testing to not get fooled by them over and over again. Now, Alice also acts like an astronomer. And the reason for this is simple. Alice knows that testing the software is more than just checking the specification of the software. So she doesn't just compare the actual software to its specification. She also compares the idea of the software to the actual software and to its specification. Now, she knows that the purpose of the software is to solve someone's problem. And therefore, she evaluates the purpose of the software too, because she knows that testing the purpose of the software is one purpose of software testing. Now, she does so because she understands that the conformance with the specification has little to no value if the software solves the wrong problem. So therefore, Alice acts like an astronomer who not only uses a microscope to evaluate the software from a rather small-scale technical perspective, but she also uses a telescope to judge the value of the software from a large-scale conceptual perspective. Alice also understands that those who cannot learn from history are doomed to repeat it. And therefore, she looks back to the mistakes she has made. She identifies patterns of failures, and she extracts the lessons she has learned. Now, in doing so, she neither denies her mistakes nor she doesn't hide them. She documents these mistakes, and then she shares these mistakes with other people. People such as developers and product owners and her fellow testers, for example. And she does that by conducting regular retrospective sessions. And in doing so, she not only learns from the mistakes of other people, she also enables other people to benefit from the lessons she has learned. So she reflects on her mistakes because when she takes on new challenges such as new projects, for example, new releases or new sprints, to prepare herself to not repeat these mistakes over and over again, because she knows that prevention is just better than cure. So the bottom line here is that Alice acts like an historian who builds a learning culture by analyzing her past testing activities to constantly improve her future testing activities. Now, on top of that, Alice also understands that having a testing specialist on the team doesn't mean to restrict the responsibility of testing to that single person. So she's aware that excellent testing is never done by one single person in isolation. She understands that excellent testing requires the collective brain power of a group of people, because she understands that great testing teams are teams of diverse talents cooperating. In short, she knows that diversity makes testing powerful. So she knows that the idea of one person having all the answers is deeply flawed. So she understands that knowledge comes in many different flavors. And so she looks for, sources of potential support. And she does that through various different collaborative activities, which we call pair testing or mob testing, for example. So she acts like a guide who actively involves, guides, and advises other people in testing by stimulating these people to continuously think critically about the software they envision, design, and build. Alice also knows that the time needed for testing is always infinitely larger than the time available. So she prioritizes her testing activities because she knows that testing has to stop, although it actually never ends. She is aware of the fact that she cannot prove the software right, but only wrong. She knows that she has to think of falsification instead of verification. And she accepts the fact that she cannot answer the question, did we find all bugs? She understands that she cannot quantify the number of absent bugs because she knows that testing can only prove the presence of bugs, but not their absence. So Alice acts like a realist who clearly understands that software testing at its core is undecidable because she understands that the problem of finding all the bugs in the software is undecidable. In addition to that, Alice knows that testing is learning. So whenever she runs out of test ideas, she suspects that she probably hasn't learned enough about the software. And therefore, she keeps exploring, she keeps investigating and experimenting to constantly evaluate this conjecture. And she never stops learning about the software and the domain in which the software is situated. She knows that testing is experimental science. And so she sees testing as an adaptive investigation rather than a factory process of creating, automating, and executing test cases. So she knows that her test success is not defined by the number of her test cases. She knows that her test success is defined by the quality of her test ideas. So Alice acts like an experimentalist, so to say, who does not confuse testing with test cases because she considers her tests as experiments to challenge hypotheses, to challenge assumptions, opinions, and various different perspectives about the software. Alice also acts like a stakeholder because she knows that testing means comparing the invisible to the ambiguous. She knows that the stakeholders' knowledge, goals, and experiences are not identical to hers. She knows that the universe of stakeholders is simply vast, but she doesn't get tired to examine risks for both internal and external stakeholders. She considers how internal stakeholders, such as product owners, developers, sales, and marketers, would look at the risks she is uncovering. And she ties these risks to their objectives, to their needs, and to their goals. She also examines risks from the perspective of external stakeholders, such as the customers and partners, for example. And in doing so, she avoids saying and even thinking things like no one would ever do that, because she knows the more advanced she gets in the software, the harder it becomes to relate to true beginners, to the end users. So she's trying to wear the end user's shoes, to not forget what it's like to be one. And therefore, she always tries to step out of her role as a software tester by taking on the perspective of different stakeholders, by looking at the risks from their vantage points. And she does so because she knows that these different viewpoints allow her to look at the value of the software and the impact of a threat against the software in a variety of ways. So she thinks like a stakeholder, so to say, to enrich the way she assesses, she prioritizes, and she analyzes risk to get a much broader picture of the overall risk profile. Now, besides that, Alice knows that she cannot expect answers to questions she didn't ask. She isn't afraid of looking stupid by asking simple questions. She understands that tests are questions. She asks the software to reveal useful information about the software because she understands that assumptions or unexamined beliefs are simply the termites in software testing. And she suspects that she probably has answers that might be wrong and beliefs that might not be true, but she isn't afraid of not knowing things. So she doesn't get tired of applying this crazy method called asking before she assumes something. And for that reason, she judges herself not only by the answers she gives, but also by the questions she asks. Because she knows that curiosity is what fuels excellent software testing. So Alice acts like a curious little kid who never stops asking because she knows that asking great questions is just the source of great testing. Now, Alice is also aware that if she doesn't have any questions about the risks in the software, then there is no reason to test at all. And if she has at least one such question, well, then she will ask, well, will these tests cost more to perform than their answers will be worth? So she acts like an accountant in a sense, because she understands that good testing involves balancing the need to mitigate risk against the risk of trying to gather too much information about the software. Now, Alice also acts like a skeptic because she knows that she shouldn't believe everything she hears and only half of what she sees. She knows that there are no facts, only interpretation. She knows that absurdity or that certainty is absurd. So she thinks critically about what she has been told about the software. And she's skeptical about what she knows about the software. And she knows that she will never know everything about the software. So she's aware of the fact that she isn't Laplace's demon, so to say. And therefore she focuses on what she doesn't know about the software. And she doesn't just settle with what she currently knows. So in short, she keeps thinking despite already knowing, because she sees testing as a thinking activity and she treats it like one. She knows that she has to change her thinking to change her testing, because she is aware that the software is a cunning deceiver that is always constantly trying to fool her in one way or another. And for that reason, she remains cautious, she remains curious, and she remains critical to not get fooled over and over again. So the bottom line is Alice acts like a cosmic skeptic because she knows that excellent testing is just the byproduct of continuous critical thinking. Now, Alice also understands that the primary goal of testing is to make other people aware of problems in the software. She knows that making people aware of problems is a socially difficult task because of the people's natural desire to avoid trouble. And she understands that problems are something negative at a glance. Now, she considers the problem as a deviation from what is perceived and what is desired. And the bigger this deviation, the bigger this gap, the bigger the problem. And the bigger the problem, the more it might threaten the value of the software. And she's also rational enough to know that different people will react differently and sometimes irrationally to potential threats. She knows that there are people, who welcome critical feedback and there are people who don't. She knows that there are people who value the perspective of others and there are people who don't. She knows that there are people who hold themselves responsible and accountable for their mistakes and there are people who don't. So what she does is very simple. She first of all realizes that the nature of humans is diverse. So she studies the people's personalities and their relationships among each other to make them aware of problems in a dispassionate, deliberate, and personal way. She understands that if she isn't making people aware of problems right away, then these problems will eventually find them. So she communicates these problems with modesty and empathy. She's direct, critical, but she's not judgmental. And therefore she talks about negative things in a positive way because she sees problems as an opportunity to improve. She knows that the software doesn't have to behave the way she wants it to behave. She's aware that she doesn't design, code, or sell the software, right? She tries to help other people to understand the software they have got so that they can decide whether it's the software they want. So she acts like a friend who reduces people's ignorance about the software without embracing arrogance. Alice also understands that software testing is the headlights, quality is the journey, and the business outcomes are the destination. So she lights the way for other people by describing the status of the software in terms of what it does, how it works, and how it might not work. She describes her testing activity in terms of what has been tested, what has not been tested yet, and what probably won't be tested at all due to several constraints, such as time, resource, and budget constraints. She also describes the quality of testing in terms of the successes she achieved and the obstacles that impeded her testing. So she not only looks for problems that threaten the value of the software, she also looks for problems that threaten testing, because she understands that problems in the process of looking for problems, testing, can prevent her from finding problems in the software. So in short, she provides a 360-degree narrative on testing packed with useful and actionable information, instead of just bombarding her stakeholders with vanity metrics that are packed into shiny but meaningless dashboards. So she acts like a storyteller, so to say, who understands that testing requires doing testing and describing testing. And last, Alice also knows that she cannot assure quality in the same way a doctor cannot assure health. She understands that her primary objective, again, is to collect quality-related information to enable other people to make better informed decisions. So in short, she is aware that she tests, but others decide. So she sees testing as an information-based science, and she understands that she provides value through testing by helping other people to provide value. And therefore, she considers herself as an assistant that neither does quality assurance nor quality control, but rather quality assistance. Now, ladies and gentlemen, this list could go on and on and on. It's not complete, and it will never be. But I hope you get the point. Alice is a cocktail of testing excellence because her testing is fast, inexpensive, credible, and accountable. Now, if that was a little bit too fast for you, no worries. You can find all the details of what I've just said in my recent article on my LinkedIn profile. And this article is simply called Excellent Software Testing. And feel free to use this article as a basis, as an inspiration to work out your notion of testing excellence. Now, here's a little secret I want to tell you, and you might have already guessed it, right? The picture of Alice you're currently looking at shows my sister. And my sister has absolutely nothing to do with software testing. So what I want to say by that is that Alice is real, but only in a metaphorical sense. So Alice is a fictional character that symbolizes the collective testing excellence of a large, inspiring and diverse group of excellent software testers with whom I had the pleasure, the honor, and the privilege to work with in the last 10 years. Now, finally, let me highlight that this short story stands on the shoulders of these giants listed on that slide. So, ladies and gentlemen, don't follow me, follow these people, because they know the way, they go the way, and they show the way of excellent software testers. And that's it. That's all I wanted to share with you. So thank you again for joining. I hope you enjoyed the session. I'm now handing back to my friend Stefan to open the Q&A. Stefan, are you ready to kick it off?